All right, this is a video on 2.7 on implicit derivatives. We're looking at how do you take a derivative with respect to x of an expression that may have variables that are x's, but variables that may not be x as well. So we're looking at what does it mean to take a derivative with respect to x of a different variable. Now, you can think of that other variable being like a function itself. So it's representing some unknown. So anytime we take a derivative and the respect of our letter that we're taking the derivative of doesn't match the variable we're looking at, we chain on the d variable dx or d variable dt, whatever we're taking respect to. So we have one phrase right here we want to do. We're taking respect to x. That is important that you always read what you're taking the respect to. So if we do d dx, which remember that's the symbol for the derivative with respect to x, of x plus d dx of 3y, the derivative of x is just 1, and that's all you need there because the x is the variable we're taking respect to. The derivative of 3y is 3, but because the y is not the correct letter for our respect, we chain on a dy dx, which represents the derivative of a function y with respect to the letter x. So that's that one. So we have a couple others. I've already set some of them up. We want to look at find dy dx for this equation now. The last one was a phrase. So we're going to take the derivative of each term on both sides of the equation, and then we'll say, okay, can we solve for dy dx? Dy dx is going to represent the slope of the tangent at a point on the function that we're talking about, just like it always does. So we're going to be looking at taking the derivative of y cubed with respect to x. So that would be 3y squared, but because it's not the right variable for our respect, we get a dy dx chained along. 5x cubed is an x, so this is going to be 15x squared. 8x is also an x, so the derivative of that is just 8. To solve for dy dx on this one, you just have to divide over the 3y squared. So that one was pretty simple. The price you pay for doing a derivative implicitly is that you end up having x's and y's both in your formula for your slope. Okay, so instead of actually writing dy dx in front of every single term, you can write it just on both sides of the equation. Just make sure you carefully look at each term one by one. So this would be 12y squared, and since y is not the correct variable, we chain on the dy dx. 2 times 5 would be 10y, and then because it's not the right variable, you chain on the dy dx. Negative y would be negative 1, and again, not the correct variable, so we chain on dy dx. Negative 3x cubed is the right variable for our respect, so this would just be negative 9x to the second. And on the other side, we just get 8. So then if we try to get all of the things that don't have dy dx on the same side together, we're going to leave our 12y squared here, our 10y dy dx, our minus 1 dy dx, and we're going to add over that 9x squared because it does not have the dy dx. The reason we do that is because then we can pull out the dy dx as a GCF. So now this is 12y squared plus 10y minus 1 equals the 9x squared plus 8. So dy dx, the derivative of the function y with respect to x, is going to be 9x squared plus 8 over 12y squared plus 10y minus 1. Okay, number 5 is going to be an application of this. So if you take an implicit derivative and you have an ordered pair, at the end you can plug in the x and the y and get your slope of your tangent line at that point. So that's what they want, to find the slope of the graph of this function at the point 0, 4. So we're going to do d dx of the left side and d dx of the right side. This would be just 2x, and then we'd have a 2y times dy dx because the letter doesn't match. Derivative of 16 is just 0. So then if we tried to solve this, we would subtract over the 2x and then divide by 2y. So dy dx is x over y. So that's my formula to find my slope. I need to find out what would be the slope of the tangent line at this specific point. So dy dx, plug in 0 for x and 4 for y, and that would be 0. So the slope of the tangent is 0 at the point 0, 4. Something we haven't mentioned a lot, but I've seen it maybe in one of the homework questions. If your slope is 0, the slope of the tangent, that means you have a horizontal tangent line. Just something to note, because that's the only kind of lines that have slope that are zeros. Okay, let's look at number 6. Because I believe, yes, we did number 7 in class, so we're going to look at number 6. Okay, so find the slope of the graph, xy minus 3y squared equals 2 at the point 7, 2. Now we're going to take the d dx, and I'm actually going to write this one out with every term because there is something a little bit more complicated about this one. And that's because the first term has both x and y in it, so that's going to be a product rule. So I'm going to come over here and do some scratch for d dx of x times y. Okay, so remember we're supposed to take the derivative of the first when you do a product rule, so that's going to be 1, times the second function. So this is for derivative of the first times the second plus the first times the derivative of the second. Okay, notice with this y right here, I did not put a dy dx next to it because it was not an actual derivative. It was just right the second function. And then for this one, the first function's x, and when I do the derivative of this, it's a 1, but you have to chain on the dy dx. So this part right here is actually going to turn into a y plus an x dy dx. So that came from my scratch work over here. The rest of them are pretty simple. This would be 2 times 3 is 6, y to the first now, and then we did use the wrong variable, so it's dy dx. And then derivative of 2 with respect to x is just 0. The only term that does not have a dy dx is the y, so we'll move that over by subtracting it. And then we can pull a dy dx out of the left side, so that's going to be x minus 6y equals negative y. So dy dx is negative y over x minus 6y. And then we want to evaluate at the point x is 2 and y, or excuse me, x is 7 and y is 2. So this would be negative 2 over 7 minus 6 times 2. So that's going to be negative 2 over 7 minus 12, so that would be negative 5. Negative over negative is positive. So the slope of the tangent line at the point 7, 2 of this equation is 2/5. Okay, we need to do 8. So find the equation of the tangent line to the graph 4xy plus x squared equals 5, and then at the point 5, negative 1. So this takes it, remember, a step further. You're going to find the equation of the tangent line after we find the slope. So we have 4, and you can pull the 4 out front of the 4xy when you do the derivative. That's just a constant, so it's okay if it's out front. It's okay if it's inside too, but with a product, I'm going to always pull it to the front. And then d dx of 5. And you're like, how do I know I have a product? Because you have two things multiplied together that are different bases or different functions, essentially, is what we're thinking of these as. Now, we already did this up here in the last problem. So remember, x times y was y plus x dy dx. So I'm going to kind of use the red to remind ourselves that I got that from up top. Oops, y plus x dy dx. So this right here was a product rule from the previous problem up top. And we'll have to distribute the 4 to that, and then we're going to take the derivative of x squared, so that's just going to be 2x, no dy dx since the variable matches, and this would just be 0. So this is 4y plus 4x dy dx plus 2x equals 0. We want to subtract over everything that does not have a dy dx, or add it if it's already negative, but this is going to end up being negative 2x and minus 4y. And I'm going to divide by that 4x. So dy dx, which is change in y over change in x, if you want to think of it that way, is going to be negative 2x minus 4y over 4x. And we're going to plug in the point 5 for x and negative 1 for y. So that is negative 10 plus 4 over 20. That's negative 6 over 20, which reduces down to a slope of the tangent of negative 3/10. This one does want us to write the equation. So here's the part that a lot of people, you get all this way through and you forget what to do on the last step. Remember, it's just point and slope. So I'm going to plug it into y minus y1, which would be positive 1 now, equals the slope times x minus x1. You could distribute here since it won't cancel out the fraction completely, but 5 and 10 divide. So that's going to be a positive when we multiply, and then it'll be 3/2. And then we need to subtract the 1 over. So if you do 3/2 minus 2 over 2, make that a fraction. This is going to be negative 3/10 x, and then plus 1/2. So there's the equation of the tangent line to the equation that we were given at the point 5, negative 1. Okay, and number 9 says find the rate of change of x with respect to p. Okay, so we're changing it up. They're doing respect to p. Now the problem is the function on the other side looks pretty messy. It makes things a little bit uncomfortable to take the derivative with respect to p when there's all these x's down here in this denominator. So I'm going to actually try to get everything on one line by cross multiplying here. So if I multiply across here, this would be p times 0.000003x squared plus p times 0.04x plus 6p equals 5. Okay, so if we work that out, that'd be 0.000003x squared p plus 0.04x p, and then plus 6p equals 5, just making it look a little bit neater. Okay, and then I want to take the derivative with respect to this. Actually, no. Let's go back one step. I'm going to make my life a little easier because notice, so I'm going to talk to you why I'm changing my mind here. Do you notice that right now I have 2 variables in the first term and 2 variables in the second term? That makes me have to do the quotient rule twice. Sometimes just by changing your thought process, you can avoid the quotient rule. I'm going to pull a p back out of all this because every term has a p. And that's not enough zeros there. So just an alternative way. You can do it the way I had it set up, but I'm actually not wanting to do the quotient rule for 2 different terms if I don't have to. So instead of distributing that p to everything, what if we left it out front? Then we can divide it over to the other side. So that would just leave us all of our trinomial right here. And this would be 5 over p. We could then write that as p to the negative 1. So then we have every term only has one variable. Therefore, we won't have to deal with any product rules. So you may not catch that. You may have done it with all the product rules. You'll still get the same answer at the end. It'll still evaluate the same, but this will be a little bit quicker. So we want to take d dp of both sides. Okay, so on the first term, we'll get 2 times the 0.000003 is going to be all those zeros still, but a 6 now, and x to the first, but because it's the wrong variable, since we're doing with respect to p, we have to tack on that dx dp, plus 0.04 dx dp, and then 6 goes away, so we don't need anything for that. This one, we'll pull the -1 to the front, so that'd be -5, and then it becomes p to the -2, and we don't need to do anything with that because that is p. Okay, so then what we do next is we have the dx dp we can pull out to the front, and that would just be 0.000006x plus 0.04 equals -5 over p squared. And if we divide over this parentheses, it's going to join that p squared in the bottom. So it'll be -5 all over p squared times that binomial. All right, and that's it. So you don't always have to take respect with x, just you have to follow the directions essentially. There is a number 10 on here. I looked through your test and I don't really want to get into doing too much with this one because it's not on the exam, so we're going to omit it. And that's the end of the 2.7.